Okay, so we are going to be doing molarity. Molarity is something that we actually use quite often in chemistry. Molarity tells us the concentration of a substance. So it's actually the number of moles dissolved per liter of solution. Remember, when we're talking about this, we'll have a capital letter M to represent the molarity. When we are talking about this year, when we did our double replacement reactions, we used a lot of things called like 3 molar hydrochloric acid. That's what we're talking about. It's moles per liter. And so this is the nice little equation that we have for that. So let's go through a couple of problems looking at that. So the first thing we need to do is break down what we have. So we want to find the molarity of an aqueous solution. Remember, aqueous means dissolved in water. And it's giving us glucose as our solute. So we have 40 grams of glucose, C6H12O6. This is going to be our solute. And it is going to dissolve in a solution and form 1.5 liters of solution. Now, a solution is a combination of solute and solvent. The solvent is not necessarily needed to figure out our molarity of solution. And so the first thing that we need to do for this, we have to convert 40 grams of glucose into moles of glucose. So we need to use the molar mass. So this is 180 grams of C6H12O6. And again, how we've solved for molar mass in every chapter since we divide by the molar mass and we get 0.222 moles of glucose, C6H12O6. Once we have that, we can put that into the formula right here. And so we take our 2.022 moles of glucose and we divide it by our liters, 1.5 liters. And it tells us that we have a solution that is 0.148 molarity of C6H12O6. So we have a 0.48 molar solution. So molarity of glucose solution. So let's do one more. This one's a pretty common one. We're going to be using bleach. If you see, we're given for this, we'll go to a fun color, 9.5 grams of NaOHCl, which is our bleach, and this would be our solute in a 1 liter of solution. So again, we need to convert our 9.5 grams of NaOH or Cl into 1 mole, and we use the molar mass for that. The molar mass is 74.5 grams of NaOCl. Divide that out, you get 0.128 moles of NaOCl or bleach. We would divide that by our 1 liter of solution that they want us to make, giving us a concentration of 0.128 moles per liter or molarity of NaOCl. Again, this solution is important because we can make stock solutions from that, knowing what that is. Let's try one more of these. So again, we're given a 0.16 liter of solution, and we're asked to take 1.55 grams of dissolved potassium bromate and figure out the molarity. So again, first step, convert grams into moles using the molar mass. Again, 3 significant digits for this. So we have 119 grams of KBr, which is equal to 1 mole of KBr. Divide that out, you get 0.0130 moles of KBr. Again, we want to divide that by the solution. 1.6 liters of solution is what we're given. And we would find that we have a molarity of 0.00813 m of KBr, potassium bromate. This would also be 8.13 times 10 to the negative third potassium bromate. So that's not so bad, but that's not how it really works all the time in industry. A lot of times when I'm preparing a solution, I know the molarity of the solution I need to make, and then I have to then determine how many grams I'm going to put in. So that's what this equation is going to do. So we're going to look at how many grams we now need if we're given the molarity of the solution. Well, we just want to simply work it backwards. 0.10 molar of CaCl2, so that's our concentration. Oops, sorry, I got a line there. Need to erase that. And we want to set that equal to X, being moles of CaCl2 over our 1 liter of solution. Well, X is pretty easy to solve for. It's 0.1 moles of CaCl2. But that doesn't give us our answer. We now have to convert that into grams of CaCl2. Knowing that 1 mole, we use the molar mass conversion that we've used for a few chapters now, with 3 significant digits giving us 111 grams of CaCl2 for the molar mass, which gives us 11.1 grams of CaCl2. Some of you might be wondering how we do this. So I would measure out this amount on a scale, and then I would take a container that looks similar to this. This is a volumetric flask. I would put my crystals in here, and then I could fill my solution up to this line. That line is actually a volume, and it's very specific. These ones are really expensive, and I don't really let students use them because they are exact measuring devices used for molarity. We have a few in our room. Let's do one more of these. So we're giving 2 moles of NaOH, a solution that we've used a lot of, a strong little base. We want to know how many grams we have if we have, or how many in sulfur moles if we have 1 liter of solution. Well, this would give us 2 moles of NaOH. We know that 2 moles of NaOH is equal to the molar mass of NaOH, which in this case, it is 80 grams of, I apologize, I'm giving you the answer. The molar mass of NaOH is 40 grams of NaOH, and the answer would be 80 grams of NaOH. Again, I would measure out this mass. I would, using a scale, because these are solid crystals, I would put it in the bottom of my volumetric flask, and I would fill it up to my 2 liter mark. We do not have a 2. We only have like a 500 milliliter volumetric flask. So in the case of that, I would have to do 2 solutions to get my 1 liter of solution. And so in this case, I would take 40 grams and put it into my volumetric flask, fill it up to the 500 mark, and then I would have to repeat that process so that I use a total of 80 grams to get 1 liter solution. Thank you.